On Mars, liquid water has been discovered not just as a tiny trickle, but as a massive subterranean reservoir that might eventually become an ocean that spans the entire planet. However, how did scientists ever begin to pursue the gushing secret of the red planet? What implications does this important discovery have for upcoming Martian colonists? Above all, is it possible that life is concealed in the Martian water? During its life, Mars has experienced many things. The celestial body can reflect on a wet and joyful past, despite its current appearance as a chilly, bone-dry world covered in rust. It is currently accepted that our planetary neighbor still had a large number of rivers, lakes, and even some full-fledged seas until 3 billion years ago. However, the Martian seas vanished, along with the disappearance of the thick atmosphere. However, where did they disappear to? To put it another way, what became of the massive amounts of liquid water that once made Mars habitable? Well, experts have been pondering that very subject for a while. The ice caps at the Martian poles are simply too small, according to data gathered during earlier research missions, to have stored all the water from the former oceans, and the water ice deposits that are dormant beneath the planet's surface in the mid-latitudes are also too small to provide an answer. Consequently, the astronomical world has come to believe that the chilly dampness departed the red planet a long time ago. The majority of the Martian water was snatched into space by the high-energy solar wind, which was able to act on Mars' atmosphere without interference since the planet lacks a magnetic field. So much for the theory then. However, what if this presumption is just untrue? What if the ocean's water was still concealed in the Martian crust's depths rather than being hauled into space? The research team at the University of California, San Diego, under the direction of Vashon Wright, was intrigued by this intriguing concept. The scientists closely examined seismological data gathered on the ground by the NASA lander InSight between 2018 and 2022 to see how closely this hypothesis aligns with reality. At that location, InSight's observations have previously revealed that the Martian crust contains very little water, but only to a depth of about 300 meters. But now, the researchers literally dug deeper into the riddle, examining what might be happening in the central crust of Mars, 5 to 20 kilometers below the surface. Although the average yearly temperature on Mars is a chilly 68 C, it might yet be warm enough in this secret subterranean realm for water to live there constantly in liquid form. Previous analyses have also demonstrated that the equivalent crustal region might be teeming with rock pores that could provide the chilly liquid with an infinite number of loopholes. In the end, the researchers integrated the seismic data with a mathematical model of rock physics, which is used by researchers on land to find groundwater reservoirs or oil discoveries, for instance. Overall, the findings were revolutionary. On the one hand, the investigations verified that several voids, comprising over 15% of the rock, are permeated throughout the central Martian crust. However, the results showed that liquid water is truly present in the relevant pores, cracks, and fissures. The enormous store of water on Mars. According to the research team, the best explanation for the data gathered is a medium-sized Martian crust of fractured magmatic rock that is saturated with liquid water. However, it should be noted for the interest of completeness that there is currently a minor disclaimer attached to this amazing announcement. It is possible that a sizable water reservoir lies far beneath the Martian surface, but this is only if the findings of the study are typical for both the InSight site and the entire planet. However, it's possible that the red planet has a groundwater reservoir that stretches throughout the entire celestial body due to its deep rock pores. That's just something we need to remember. Mars was once thought to be the perfect example of a dust-dry desert planet, but according to the researchers' calculations, the planet's central crust has enough water to support a global ocean that would cover the entire surface and reach depths of 1 to 2 kilometers. However, the poor water reservoir may potentially provide an explanation for the water loss. In this case, the planet would have merely moved its moist face to space, rather than losing it to space due to atmospheric outgassing. This suggests that most of the ancient Martian oceans may have soaked into the planet's crust, where they have remained preserved as pore water to this day. A totally other concern suddenly emerges, though when the astronomical divining rod fails, what does the deep water reservoir portend for future Martian astronauts? Men like Elon Musk, after all, are known to have aspirations of both becoming the first to send a human to Mars in the near future and eventually constructing permanently inhabited stations on our neighbor. Would it be possible for future Martians to just scoop water from the subterranean reservoir? Not really, though. The reality is that drilling equipment just cannot penetrate that deep. However, this does not negate the importance of the Martian water for research, even if we are unable to obtain it. Conversely, the finding of water provides a unique window into the red planet's climatic history, according to research co-author Michael Manga. However, the secret water reservoir is also thought to be a location where life may have existed in the past or may still exist today. The origin of life on other worlds? The mythical Martians would undoubtedly feel comfortable in a real-world severe environment. However, there is no denying that we are aware of certain terrestrial animals that thrive in these harsh environments. For instance, there are the sessile organisms that resemble sponges that were found beneath the thick Antarctic ice sheet a few years ago. These strange animals slept 900 meters below the surface, yet they thrive in a setting where sunlight and steady food supplies are alien ideas. The residents of the so-called deep biosphere are also real survivors, even though black smokers at the bottom of the deep sea are occasionally even thought to have cleared the path for the emergence of life on Earth in the first place. The majority of the cellar dwellers on Earth are bacteria, viruses, and fungus, which exist not just in ocean sediments, but also in volcanic rock and even in the continent's kilometer-deep bedrock. And why should life on Mars be any different if the perpetual darkness and oxygen shortage aren't enough to extinguish it on Earth? Michael Manga, however, is equally curious about this. He also doesn't understand why Mars' subterranean reservoir shouldn't also be a life-friendly planet, given that water is a basic requirement for the emergence of life akin to that on Earth. However, Manga stresses in the same sentence that there is currently no proof that Martian life exists. However, at least we now know about a location on the red planet that may theoretically support life. Have we already discovered the signs of Martian life? Well, one thing at a time. Perhaps yes, but perhaps no. At Jezero Crater, the Mars rover Perseverance, which has been in operation since February 2021, discovered a rock that is currently generating a lot of media attention. It is roughly 1 m long and 60 km wide. The reason for this is that the rock has some eye-catching patches that might be signs of chemical processes that microbes employ to generate energy. Spectrometer analyses have revealed the presence of organic carbon molecules in the spots and their environment. The Martian signs, together with the iron and phosphates that have already been found, are similar to the remnants that bacteria frequently leave behind on Earth. More precisely, fossil indications of subterranean microbial life are frequently linked to similar deposits on our home planet. For instance, these microorganisms usually break down iron oxide, which releases iron and phosphate. Our results suggest that the water that formerly flowed over Jezero Crater likely produced the optimum conditions for rock life to thrive on Mars. Does this, however, provide a definitive response to what is perhaps the oldest issue in human history? Is Earth the only planet in the cosmos to have supported life? Not exactly, actually. Although bacteria are frequently responsible for the formation of organic molecules on Earth, they can also form abiotically, geochemically, without the assistance of living organisms. In light of this, it is also possible that Jezero Crater is just the product of volcanic activity rather than displaying signs of bacteria. The experts cite a grain of the mineral olivine, which is thought to be a common component of magma and was also discovered in the rock, as evidence for this. As a result, the Perseverance finding at this time poses even more queries than it resolves. Unfortunately, it will also take some more time until scientists have figured out the Martian boulder's actual origin. The reason for this is because the Mars rover's analytical skills have reached their limit. To find out what actually caused the enigmatic spots to appear, the researchers have already filmed Jezero Crater from every angle and subjected it to X-rays and lasers. Therefore, transporting the rock sample to Earth and using high-precision analytical tools to study it there is crucial. But just as the answer to whether Martian bacteria were actually at work here is still in the stars, so too is the date and method of the comparable Mars sample return mission. You can now go ahead and click the subscribe button to get started. Join our community now to ensure you never miss another thrilling video from us. See you soon.